Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to begin the lesson logical reasoning. Okay, so by the end of this lesson, you should know what a statement is. Okay, you should know what an Euler's diagram is. And you should know all the terms or the keywords that you need or you have to look out for whenever you are giving statements which would need, okay, the Euler's what diagram. And above all, you should be able to determine the validity or otherwise of certain statements based on already given premises or statements. So after you've drawn your Venn diagram, which usually will require the use of the Venn diagram, which is also known under logical reasoning as what? As Euler's what? Diagram. Okay, so quickly, I'm going to hit on the basic information that you need. You know we are working against time. Okay, however, if I move at a pace or if I say something that, okay, doesn't really sit well with you, please don't hesitate to let me know. Okay, Kobe, I know you have done this. Okay, as for the GIHIS students, I'm not sure, unless maybe they have studied or they did it outside, okay, campus. But on campus, I'm not sure, none of them. Okay, so Kobe, I'm going to be on you. Okay, you answer or I will pose most of the questions to you. Okay, at least to help us, okay, better the understanding. Okay, so this is all about logical reasoning. Okay, so with this particular topic, okay, please, we all reason. As for that one, we all reason, but not everyone reasons, okay, logically, unfortunately. Okay, so today I will be able to make that determination that whether you are able to reason logically or not. But okay, that is the, oh, you haven't done logical reasoning, Kobe. Or you studied it on your own? Because I thought maybe you said that the only topic left is what? The dynamics. Okay, all right then.
That's for EMAT.
That's for EMAT. Okay, so it means
For core math, we've not done logical reasoning because it's just that there's no need studying it because it doesn't really come.
But for the past 2 years it has
All you
come.
have to do is to know that.
No, have you
What you
realized
said was
for the
that
past 2 years it has come? It came in the past two
I
years.
haven't really seen the trend.
You haven't seen.
Like I haven't gotten
Okay, the
access
past
to
two
most of the
years,
papers.
okay. So that's the more reason why for a long time it used not to come. Okay, but now, okay, I mean, because most students want to be lawyers, basically. Okay, a lot of the well, even the science students, some of them want to be lawyers. And because logical reasoning, okay, if you want to be a lawyer, okay, please, you have to like this particular, okay, topic. Because basically, lawyers, that's what they rely on. All right. Okay. So if none of you, then it means anyway, I will pose the question to everyone. Okay. So please, okay, make sure you ask all the necessary questions. And like I said, I'm only going to, okay, hit on all that you need to know. I mean, the basic stuff. Okay. And give you hints how to maneuver your way around. So if my method or my route, okay, will not sit well with you as usual, let me know. I'll find another way to, okay, explain for you to get it. Okay, so logical reasoning, like I said, here you basically, in terms of core math, we have relative math. So in terms of core math, usually you'll be given statements, and out of the statements, you'll be asked to draw a Venn diagram. However, okay, that Venn diagram, its actual name under logical reasoning is Euler's diagram, Euler. So if you don't see Venn diagram and you see Euler's, it's the same thing. Okay, only that, okay, Venn diagram came before Euler's realized that you can equally use a diagram based on rectangle and circles, okay, to reason logically. But the diagram based on circles and rectangles came from that man, Venn, John Venn. So it still takes its root from what? Joint Venn. That's why still we call it what? The Venn diagram. Only that usually we say the Venn diagram will be for sets. But under logical reasoning too, we are going to basically deal with sets. Only that is set under logical reasoning. So take note. So if you don't see Venn diagram and you see Euler's, okay, you know it's the same thing. Don't say that you are not taught. It's the same thing. Okay, and whenever, okay, you are drawing the Venn diagram or the Euler's diagram, when you are giving statements, and you know that statement in English, we say that statement, okay, indirectly, okay, let me ask, what is a statement? What is a statement? Okay, so can we say that a statement is any sentence that is either true or false, but not both?
Yes, please.
Okay, I can say yes, please. Okay, so that's it. So we'll be dealing with statements, basically. Okay, and the statements will connect sets. So you use, okay, your English to bring out the set, and after that, you deal with it mathematically. So this is it. And I was saying that you need to look out for certain keywords. Let me put it this way. I wanted to, okay, quickly. Let me clear this. Okay, so we'll be looking at some keywords. Okay, because you'll be drawing circles, sets, and you know that in set you will have either the circles drawn will overlap, they will not overlap, okay, or one will be contained in the other. So these are the three possible ways that you can, okay, draw your, okay, set, represent your set. So the first keyword you can see when you see all, okay, when you see every, okay, or its associated synonyms. Okay, you should know that we are talking of subsets. Okay, so in that case, if you are drawing your circles representing the two sets or the set that you are given, usually it will be two per statement. Okay, you draw it this way. Remember, we said it will be a subset. So you have a bigger set and a smaller set. Okay, so in this case, I can say, if I say all A's are B's, then it means, okay, the smaller set will be A. So A will be contained in B. Do you get the point?
Yes, please.
Okay, so if I'm drawing this, then my A will be the smaller set and B will be the bigger set. So what comes, okay, the set that comes immediately after that keyword, okay, becomes what? The subset, the keyword or every. Okay, take note. Okay, so now you come to two. Okay, another keyword that you need to look out for will be, okay, some. Okay, not all. Okay, and its associated, okay, synonyms. And that will give you, okay, intersecting sets. Okay, so take note. So on that note, if I say, okay, that some A's are B's, okay, then indirectly, I'm looking at the situation. If this is my A, this will be my B. So they will overlap. So AB. Is my point well made?
Yes, please.
Okay, and last but not the least, okay, we have, okay, another keyword or so no, none, or its associated synonyms, and that will give you disjoint sets. Okay, so in this case, I can have, okay, no A is, okay, a B. Okay, so now what do we do in that case? If this is your A, okay, that is your B, they don't have anything in common. So this becomes your set. Okay, how you represent. Any questions so far? Are you all fine?
Yes, please.
Yes.
Okay, very good. So these are the keywords that you have to. So anytime you are drawing your circle, take notes. Okay, and as we move on along, okay, I will give you, okay, certain tidbits as well. Okay, so now that we have that, anytime you are giving statements, and out of the statement, you are asked to draw your Venn diagram, usually you'll be asked to use the Venn diagram, just like said, when you draw the Venn diagram, you'll be asked or you'll be required to use the Venn diagram to answer some follow-up questions. So usually you'll be asked to determine the validity or otherwise, okay, of giving statements based on your original, okay, statement. So, and your original statements usually are called your premise or premises. Okay, that's the foundation of your argument. Okay, in law, that's how, because so in this case, okay, this is what you need to know. You equally need to know what a valid, okay, statement is or a valid argument. So let me write valid argument. Okay, so valid what argument? And if you want to write, you can write this. Okay, an argument is basically said to be valid, okay, when it follows from, I mean, its conclusion basically follows from a given set of premises. Okay, so you let me write, okay, an argument is said to be valid when its conclusion follows necessarily follows or follows necessarily from a given set of premises. And premises, remember I said, okay, that is what makes, okay, I mean the foundation of the argument. Okay, so usually, okay, the same thing. I think I've been using this. Let's say if you are asked to determine whether or not an operation is commutative, you start by saying that an operation is commutative. Okay, maybe the operation star is commutative if A star B is equal to B star A. So that condition that you've stated there, okay, is your premise. That's the foundation of your argument. So if you continue, okay, with your argument and you realize that your foundation is satisfied, then you draw the positive conclusion. Okay, otherwise you draw the negative conclusion. So if you know the definition of a valid argument, then you should know that of what? Okay, the not valid argument. So in this case, okay, I can write or otherwise it is, okay, not a valid, a valid, okay, argument. Okay, so the negation of that. So if it doesn't follow, okay, the conclusion doesn't follow from the given set of what premises, then you will say that your argument is not valid or is invalid. So please take note. Okay, so quickly, let's go and have a taste, okay, of, okay, whatever I've said so far. Okay, I think at this point I have to go back to, okay, the normal view. Okay. All right. So let's see. Question 1, work the example 1. Okay, consider the following statement. And here you are given only one statement. And usually the statement will be given a name. So the statement is given a name P. Okay, all rich people are hardworking. Okay, so in this statement, every statement that you are giving, and you will use to draw. Remember I said, look out for your keywords. Okay, so let me make this a little, okay, big so that you can have a better view. Okay, so let me equally, oops, okay, all right. So now if you look at this clearly, you can see that in the statement, we have is only one statement, all rich people are hardworking. So in this statement, we can see our keyword all. Is my point well made?
Yes,
Yes,
please.
Okay, and again, if you look at the statement, how many category of people can you see? Or how many sets of people can you see there? In the statement, how many?
Three.
Three, okay, name them.
Kofi, Amma. Sorry, there are four.
They are four. No, I'm talking about not the name. So the statement, please don't come down. I'm still here, up here. Okay, don't jump the gun. So in this statement, how many sets, okay, can you, or how many category of people can you, okay, get from your distinguish from the statement that you have there?
Two.
Two, which will be?
Rich and hardworking.
Very good. Okay, so it means now we are able to define our sets. So this is how you are going to proceed in terms of what? Your definition, I mean your presentation, I should say. So the first thing that you write, you know, okay, solution after underlining the salient part, which is your keyword. Oh, okay, you come and write solution. Okay, then just like sets, you know that whenever you are dealing with word problem in terms of sets, you start by writing let. You have to define all your sets and the consideration. And the first set that you define usually will be your universal set. So in this case, I'm going to write let's, okay, mu be equal to a set of people. So in this case, obviously you can see that we are dealing with, okay, a set of people. Is that clear? So that will be our universal set. Out of the set of people, we have rich people and hardworking people. So in this case, I'm going to use R. So if you have space, you continue. It's better to extract row-wise than column-wise, especially, okay, in relative math, because you want to conserve space. Okay, so in this case, I will come down because I know it won't go there. My next set will be R. So I will use R to represent, okay, a set of what? Rich people. Okay, or rich. Okay, I can just write rich because R will be a subset of that. So if I say rich, I'm talking about rich people. Is that clear? Okay, and okay, your last set will be hardworking people. So I'll use H to represent a set of what? Hardworking people. Okay, so that will be it in terms of your set. However, apart from your set, okay, the statement that you'll be giving for you to determine the validity or otherwise of your argument, okay, please take note. Usually we'll have some names. So the names too must be defined or represented by letters. However, when you are dealing with the names, in terms of the representation, you don't use capital letters, you use small letters. So it's the set that you use capital letters, okay, however, okay, you use small letters for the name, so please take note. So in this case, okay, I am going to write, I can see Kofi there, so small k, okay, for, okay, to be equal to what, Kofi? Okay, then what else? I have, okay, A, so small a will be for Amma. Any other name, I have AC small e, okay, sorry, forgive me for AC. Okay, let me write AC. I can equally be smart. It's equal to small a. It's the same thing. Exactly. Oh, small e, forgive me. Small e, I meant that. Okay, forgive me. Okay, so small e. Oh, now let me clear and do the right thing. I didn't want to go and pick the eraser. I was destined to pick it, so I have to. All right, so E will be equal to AC. Okay, and we have last name Kojo, but because you have used K, okay, please, you cannot use K. And again, in maths, I've told you that in maths, anytime you are at liberty to introduce any letter, okay, to represent anything, don't go for O, because you can confuse it with what, 0. So in this case, okay, maybe O would have been, but because of this obvious reason, we'll skip O and go to the next one, which will be J. So I am going to write, and okay, small j will be for Kojo. Is my point well made?
Yes, please.
Okay, so now let's come to, okay, how to draw our Venn diagram using the information that you have here. And the Venn diagram, you use only the statement. So that's why I said, draw a Venn diagram to illustrate the above statement. Okay, it's later that we'll come to this. As you read the question, like I said, you know exactly what to do. Some will draw the Venn diagram before they will come and, okay, write, okay, this representation. So after the A, when they come to the B, then they will write, let's, okay, K, small k, whatever you have here, okay, represent that. So it's the same thing. Okay, you can do that also. So now let's see, okay, how best we can, okay, draw. So you know that for Venn diagram, usually we have to draw or indicate what do you call it? Our rectangle. So our rectangle is already indicated. We have 2 sets. Okay, so now I'm going to draw my first set. But because I know, okay, that my keyword there is all, so it means my second set, which will be represented by also another circle, will be inside the bigger circle. So it means I'm going to have 2 sets, okay, but one will be a subset of the other. So this becomes the picture. All correct. Let me make it a little small.
Yes, please.
Okay, all right. But you know, just like Venn diagram, immediately you have to, okay, label. So this will be your mu, okay. This will be, which one will be the subset? Is it R or H? Which one will be the smaller set?
R.
R, okay, so R or R will be what? H. So as for our Venn diagram, which is question A, okay, treated and discharged. Questions are numbered because your solution, you should number as well. So that is gone. Now we come to B. This is where the real deal is. Okay, so B, we are going for I. And like I said, some will just define, okay, and come and define the sets here. Maybe going forward, I can also do that for you to know that that is also, okay, good to do. So in this case, I'm going to go for I. Okay, this is the trick. Okay, at this point, you relax. This is the trick. Okay, so B, we are supposed to state, okay, whether the following statements are valid or not valid from the statement P. Okay, so this is going to be our argument. So Kofi is hardworking, therefore Kofi is rich. So you can see that you have 2 simple statements here, joined with therefore making it a compound statement. Is that clear?
Yes, please.
Okay, and your compound statement, this is what you do with it. Okay, so all the statements that you'll be asked to determine validity or otherwise to always be a compound statement. So the first part of your compound statement, okay, that is what you use to place, okay, that name. So this is what I mean. If you look at this, we are told that the first part of the compound statement, Kofi is hardworking. So it means Kofi must be in which circle? The circle for H, is that not it?
Yes, please.
Okay, so you have to go and get all, you use, okay, the first statement to get all the possible positions. I mean, all the possible positions for what? For K. In this case, Kofi. So this is what we are going to do. So if Kofi must be inside the circle, okay, H. Okay, originally, if the circle H is there, with no other circle inside, you have only one region. I hope you are with me. Immediately I introduce another circle. How many regions, okay, can you see for H?
2.
2. Okay, so it means K must be in 2 possible regions. So I'm going to use, usually when you are indicating the name, you put a dot there. Okay, so dot, okay, then your K. That is one possible, okay, position for K. And also I have another possible position for K, which is inside a small circle. All of them, K is inside H. Is that clear? Hello, is that clear? Okay, so the first part of the statement, I said, what did you do? What are you supposed to do with it? What do you do with it? First part of the statement, what do? You use that to position, okay, K for all, okay, its possible positions. Is that clear? So you use it to place K in
Mr. Akman, can you please come again?
Okay, I'll come again, no problem. I said you agree that this statement is a compound statement linked with therefore. So obviously, if I look at what the first part of the statement, after the therefore will give me another statement. But I said always you use the first part of the statement, okay, to place your name or to get the possible positions for your name. So you can see that we use, okay, Kofi is hardworking. So we use this K is for Kofi. So K is hardworking, meaning K must be in H. So if K must be in H, then K must be here and it can also be here. Because if K is here, K is still in H. If K is here, K is also in H. So if K is in H, then this will be the 2 possible regions that K can be located. All the possible regions. K cannot be outside, okay, H. It should be inside what? H. And inside H, you have 2 regions, this region and this region, making it, okay, these 2, okay, the possible regions that K can be placed. Is that clear?
Yes, please. Thank you.
Okay, and you use the second statement to do your arguments. So usually, the purpose is to counter. So if you are able to get a K, okay, who is, no, you can see that this, you are saying that it's rich. So if you're able to get a K who is in H, but who is not rich, you've been able to counter. So when you're able to counter, then you can say that the statement is what? Is not valid. If you are not able to counter, then it means the statement is valid. Don't worry, this is it. Okay, let's look at the first K. Okay, let me start with this K. Okay, this K, okay, is hardworking. Is that not it? This K
Yes,
is hardworking. Is this K rich? If it is rich, then it should be inside the circle for rich. Is it?
Yes, please.
Okay, let's come to this K. This K, is it hardworking?
Yes, please.
Okay, this K, is it rich?
No, please.
No, so you can see that you've been able to counter this second statement. You have this position to counter. So it means I have, okay, Kofi, who is hardworking but not rich. So the fact that Kofi is hardworking doesn't mean Kofi automatically will be rich or necessarily will be rich. I don't know if you get my point. Today, I know I'm going to talk a lot. Okay, in fact, you're also going to talk a lot. So this is the first example. Don't worry. As you move on, you see that it's very, very easy. First part of the statement, tell students, use it to position. Second part of the statement, use it to perform your argument. Try to counter. If you are not able to counter, then you draw your conclusion that it is what? Valid. If you're able to counter, then it becomes not valid. So here, were we able to counter? Were we able to counter? Do we have a counter argument that, okay, Kofi being hardworking doesn't mean Kofi is what? Is rich from what we have here. And obviously, I have a K who is hardworking H, but who is not R, who is not what? Rich. You can see that. So I've been able to counter. So in this case, my conclusion will be not valid. We were never taught this, okay, in school. Okay, even our time, we were never taught. So for me, you know, sometimes some of these things, our time, it used to come. So you have to find ways and means You have to be smart. So even if you are able to draw the diagrams for the diagram some way, somehow we are able to draw. Okay, but how to do the test or check the validity or otherwise of the given statement, that's where usually the problem is. Okay, because we were not taught, we really know the technicalities. Okay, like I'm feeding you with that information. So usually this is what I do. Okay, when I get here, okay, I can write, okay, I just gamble. All of them I can write maybe not valid, not valid, not valid, not valid. No matter what, I will get some. Or I write valid, 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 valid. Okay, no matter what, I will get some. And now, okay, it's possible that all that you have there will be valid. So if you go and pick not valid, it's possible you get everything wrong. Okay, but at first, it will be a mixture. So when you study the pattern, then that is how you play along. It's better than you leaving it blank and scoring 0. You get the point? But you are not going to do that. Okay, you will be taught for you to do your argument, okay, rightly. So now this is it. Should I come again with the first one?
Yes.
Okay, so where exactly do you want me to? Who is that, Princess? Is that you?
Yes, please.
Okay, all right. Okay, so as for the position, are you okay with the placement of K?
Yes, please.
So now, remember, so you are going to do this argument. K is hardworking, therefore K is rich. This K, hardworking, therefore K is rich. Okay, now let's come to this K. K is hardworking, therefore is K rich?
No, please.
No, so it means you counter. You've been able to counter because you have a K which is rightfully placed. Okay, but in terms of your argument, it is a counter argument. K is hardworking, but K is not rich. So you just write not valid. So you always use the key words here. If what you have, sometimes to be valid or invalid. So if it's invalid, you write invalid. Okay, that's the negation.
Yes, please.
Okay, so that will be I. We will do more, don't worry. So you get all the tricks. So this one is to whet your appetite. If it doesn't do so, then it means the future will be bleak. So please make sure you get this one. So let's go and look at II. Okay, II, what do we have? Ama is not hardworking, am I right?
Yes.
Okay, so implies, you can see that implies, okay, equally will be one of the ways that we use, okay, one of the, forgive me, okay, conditions that will, conditions that we will use to, okay, join two simple statements, making it what, a compound statement. So before your implication is a simple statement, after your implication is what, a simple statement. And like I said, before is what you use to place, okay, your name in all the possible regions. And here, it should be in all the possible regions. If you leave one region, it's possible that maybe that one region is the one that will counter. So if you leave a region not attended to, okay, it can be problematic. So now let's see, what do we have? We have Ama is not hardworking. So if Ama is not hardworking, can Ama be in the circle for H?
No, please.
So Ama is supposed to be outside the circle for H. So Ama should be in this region, anywhere outside H. Is that not it?
Yes.
So it means there is only one possible region for Ama. Unlike the other one, the K, we had two possible regions. And Ama is represented by which letter?
Small a.
Small a. So remember, I said don't just write A there. You write what dots, then A. You can position it anywhere outside. It could be here, it could be here. Once it's outside, it's okay. Okay, now we want to see if you, this only position that we have here will counter the second statement. Okay, so Ama is not hardworking, implies Ama is rich. Ama is not hardworking, this is outside hardworking. Okay, it doesn't really say that Ama is rich. If this statement is true, then it means this A here, all the A's must also be in H. sorry, in R, which is representing rich. Is that clear? So this Amma is not hardworking and it's not rich. Am I right?
Yes, please.
Meanwhile, what you have here, we said, if you are not hardworking, you should be rich. Meanwhile, what you have here, you are not hardworking, but you are not rich. So have you been able to counter? Hello, have you been able to counter or not? Hello, my professors, are you there?
Yes.
Have you been able to counter, or you want me to come again?
No, please.
Okay,
Yes,
so
please come again.
okay, let me see the one who said I should come again. Who was that? Irene, okay, all right. Okay, so now this is it. As for the placement, it shouldn't be a problem. Okay, it's the second one that usually is a problem. So let's see, Amma is rich. So here we are saying that you should get, if, okay, from the statement that we have here, it means if I have Amma outside H, Amma must be in R. But I have Amma outside H, but Amma not in R. So it means obviously this position, even this region is what is not conforming to the statement that we have here. So it is a counter statement. I have Amma outside H, Amma not in R. But the statement here is Amma should be outside H and Amma should be in what? R. But Amma is outside H, Amma not in R. You get it?
Yes, please.
Okay, so that will not be conformed to what you have there. So it will be not what? Valid. All correct.
Yes, please.
Okay, so now we move on to III. Okay, III, what are we looking for? What is the name?
AC.
AC is rich. Okay, so meaning where are we supposed to place AC? Which region?
R.
Okay, in the circle for R. And in the circle for R, you can see that there is only one region. Please, are you following?
Yes, please.
Okay,
Yes,
this
please.
question, please, logical reasoning, you have to get it. Okay, I mean, one of the easiest, usually. Okay, and the questions will always be very simple for you to relate. Okay, so now I am going to position my, okay, E, which is inside the, so dot E for AC. All right, so how many regions were we able to place AC? Only one. So we use that only one to do your argument. Okay, so AC is rich. Okay, therefore AC is what? Hardworking. So it means my AC must be in R and also be in what? In H. Is that clear? And end up being
Yes, please.
H. Okay, so now let's see. This E is in R. Am I right?
Yes, please.
Okay, and you can see that always your first statement will be, okay, the answer will be yes, because that's what you use to place the E. So it's your second statement that it will be yes or no. Okay, so I have E being R. Do I have E to be hardworking?
Yes, please.
Yes, E is in the circle for H. I hope you get it as well.
Yes, please.
So that will make the statement what? Valid, because we're not able to counter with that, okay, one position, okay, for the E. Kobe, are you following? Is Prof. Kobe around?
No, please.
Okay, let me check. Okay, I think it's network. Okay. Please, Princess, are you fine? Okay, Prof. Bennett.
Yes, please. I'm fine.
Mr. Heckman, please, are you saying that if a letter is in the smaller circle, it has to be in the bigger circle automatically, and vice versa?
Come again. Let me understand you perfectly before I say, okay, whatever that I would say.
Okay, I'm asking that if you write a letter in one of the small circles,
Mhm.
in the small circle,
Mhm.
automatically doesn't mean like it's in the bigger circle. And if you
Yeah,
write a letter in the bigger circle, does it mean it's in the small circle?
no. Okay, so you can see that if you are in the smaller circle, you are in the bigger circle because the smaller circle is inside the bigger circle. I hope you get it. Okay, so it's just like, let me take Kakumodo, okay, and Wesley Girls. Wesley Girls is contained in Kakumodo. Am I right? Okay, so if you are in Wesley Girls, you are in Kakumodo. Am I right?
Yes, please.
You
Yes,
can be in
please.
Kakumodo and not be in Wesley Girls. You get the point. Or you still want me to come again? So if you are in the smaller set, okay, you are automatically in the bigger set. That's why you are a subset. How do you take that to be a subset? If you are a subset, then you are, let's say, let me take, if I have maybe set A to be equal to 1, 2, 3, 4. Okay, set B to be equal to 1, 2. If you are in B, are you not in A? Benin, are you there? You brought this question, so I expect you to respond. Oh,
Mr. Hakman, please, my network.
Your network, wow. But
Your
you are
voice
able
was
to relate.
breaking.
You are able to relate, right?
No, please, I did not hear you.
Wow. Okay, so I said, let me use this. Okay, let me end here. Okay, maybe later when you get the video, so this is a subset of this. You agree? B is a subset of A.
Yes, please.
If you are in B, are you not in A?
You are.
But if you are in A, okay, are you automatically in B?
No, please.
No, you can see. You have some of the elements in, unless maybe we are talking about what? The other subset. We have two subsets, the proper and the improper, the one with this. Okay, but my point is well made. If you are in the bigger, okay, circle, the bigger circle will give you two regions. Okay, this region and this region because of the smaller circle here. However, if you are in a smaller circle, you are only in one region. So that's the more reason why if you're in the bigger circle, you can be outside this circle, which is the R, or the smaller circle, or you can be inside. But if you are inside the smaller circle, you are automatically inside the bigger circle. If you are in Wesley Girls, automatically you are in Kakumodo. But if you are in Kakumodo, it doesn't automatically mean that you are in Wesley Girls. Is it clear?
Yes, please. But Mr. Hackman, the first one, the I, how did the K come inside the small circle?
Yes, because we said Kofi is hardworking. So if Kofi is hardworking, Kofi should be, I can see that I said that's what I have here. Originally, if you draw your circle for H, only one region, is that not it? But immediately
Yes.
I introduce another set because that's it. It means if I'm inside H, I should be here, okay, or here. I have two possible regions. Because if I come and place it only here, okay, it means I've left this one out. If I place it only here, I've left this one also out. So once you are in the set what H, you should be in two regions. So in the same way, if I have three, let's say, subsets, I have another one here. And this is H, this is maybe A, B, okay. And if you are told that you are in H, okay, you should be here, you should be here, you should be here. So you have three possible regions. That will denote that you are in H. You get the point. So if you are a K and you are here, are you not in H?
Please, you are.
If you are here, are you not in H?
Yes, please.
So it means this will be the two possible regions. If I leave this one out, obviously, okay, you can see that I've left a possible region out. If I leave this one also out, a possible region left out.
Mr. Hackman,
Yes, please.
But why is it that the AC is rich? It's just one E that's in there.
Yes, because the circle from rich, okay, is only one circle. You can see there is no other circle inside. So if you are in R, this is the only possible. You get it?
Yes, please.
Because immediately you go outside R, okay, you are no longer in R. So you cannot be outside, okay, this circle. You get the point?
Yes, please.
Oh,
Thank
Prof. Sally, you are here. Today your network is better.
you. Yes, please.
Okay, I hope you are following.
Yes, please.
Okay, and Mami Jan, please, okay, you know, ask questions, okay, as they are asking questions. So if you don't get it, please let me know. Don't wait till the tail end. Okay, don't let what happened this morning happen again.
Mr. Hackman,
Yes, I'm here. Inshira.
please, I still don't get why I is not valid.
I is not valid. Okay, I
Yes.
is not valid because remember I said, okay, you said Kofi is hardworking, Kofi is rich. So if you are able to get a Kofi who is not rich, it will counter. So this K, is it rich?
Yes. Yes,
Okay,
please.
so you've not counted, but you've not exhausted all your Ks. So you cannot use only one K. So move on to the other one. This K, is it rich?
No, please.
So it means, obviously, you can see that Kofi is not rich. You have a Kofi who is not rich, but what? Hardworking. So the fact that Kofi
Please,
is
the
hardworking,
condition.
come again.
I was asking something.
Okay, go ahead.
So please, does it mean that the condition must apply for all the possible outcomes of K or the letter that is given?
No, I don't get you. Come again.
As in, if we have 3 E's, you are supposed to make sure that there's no counter for all 3.
Yes. So if you are able to counter one, you have one counter is necessary and sufficient to say that it's not valid.
Okay.
You get the point?
Thank you. Yes,
okay.
Please.
All right. So it's just like I say Mr. Hackman is a man. If you're able to get a feature of me, one feature, okay, which will indicate that I'm not a man, then that's sufficient to say that I'm not a man because you should know all the features of a man. I hope you get my point.
Yes, please.
You don't have to say that, okay, all the features, okay, must satisfy that of a woman before I will be, okay, I will be considered as a woman. Immediately I see one feature, okay, which is not that of you, I can say that then you are not a woman.
Okay.
You get the point?
Thank you.
Okay, very
Yes,
good.
please.
So one is necessary and sufficient to counter. However, if you want to say that, okay, you are not giving the counter statement, then it should all satisfy. But the counter, you just need one position, one place for your name to counter. Just one is sufficient. Okay, Kukua, Prof. Kukua.
Mr. Hackman, please, can you go over the I and the I again?
Hey, we'll do more, don't worry, we'll get it. If in terms of the going over, when you get the video, then you listen again. Because we have to count. Okay, we are almost 1 hour, we are still on one question. Okay, so don't worry, do more, so definitely the understanding will come. Okay, if it doesn't come, get it. But that shouldn't stop you from okay. All right, so now let me go to the last one is what? Okay, let me go back. Let me edit what I have there. Okay, MC. Okay, so Ivy. Okay, all right. So we are looking at Ivy. And Ivy, what do we have?
Kojo is not rich.
Okay, so Kojo is not rich. So if Kojo is not rich, okay, how many possible regions, okay, can we get for Kojo? Then it means Kojo is supposed to be outside R. Is that not it? And Kojo is J. Do you agree? If you are not rich, then it means you are not inside the circle, you are outside. Because this circle inside is for the rich. You get it?
Yes, please.
Okay, so if you are outside, is this the only region that will tell us that you are outside R?
No, please.
Okay, you can see that you can also be here. You are still outside R.
Yes, please.
Please, do you all agree? Are you following?
Yes, please.
Yes,
Yes,
please.
Very good. Okay, so it means, okay, J dot J, you get one dot J here. You can get one J also outside. Is that clear? So this will be all the possible positions for J. You've not left, okay, a single one out. So if you are doing your argument, you can do it well. Okay, so now let's look at the second part of the statement. Kojo is not what? Hardworking. So it means if I'm able to get a J who is in H, okay, then it means I'll be able to counter this statement. So can you see any J who is in H? Are you able to get a Kojo who is hardworking?
yes, please.
Okay, and you can
Yes,
see that this will satisfy. So once you have even one, okay, making the statement that you have here, I mean, as a counter statement, then you will say that what you have there will be not valid. Should I come again?
Yes, please.
Yes, please.
Now I am seeing those who are not reasoning logically. Okay, I've seen
No,
them.
no, no. Mr.
Okay, so let's see, not what valid. I'll come again, don't worry. Okay, very soon, I've told you, all of us will be logically after this. Okay, that's the more reason why we are doing this. Okay, so I will go over. As for the placement, are we all fine?
No, please.
Oh, let
You
me
said
see
that.
the no.
Please, you said Kojo is not rich and he is not hardworking, but you put Kojo in the H.
Relax. Use the first statement. The first statement is just Kojo is not rich. You use only the first statement to position, to place. So this shouldn't come in now. Is that clear?
Okay. Yes,
Remember I
please.
said, use the first statement, okay, to place, and you use the second statement to do your arguments. Is that clear?
Yes, please.
Okay, so don't box the two together. So Kojo is not rich. The first statement, meaning Kojo is supposed to be outside R. Is that clear?
Yes, please.
Okay, so outside R, one is this, one is this. So dot J, all correct.
Yes, please.
Okay, we are going to use the second statement to do our argument. Okay, so if you're able to counter, so it means Kojo must be outside. So the second statement means Kojo must be outside what? H. But if you are able to get a Kojo who is inside what? H, okay, then you see that what you have here will not be valid. So I'm able to get a J who is inside what? H. So it means I can get a Kojo who is not rich, okay, but what do you call it? Hardworking, because we said Kojo is not rich, meaning really Kojo must be what? Must not be what? Hardworking. But I have a Kojo who is not rich, but hardworking. So the fact that Kojo is not rich doesn't necessarily mean Kojo is not hardworking. You get the point from what we have here. Okay, so as simple as that. Okay, so you need to get that this one is for two circles, and usually, okay, you won't get two circle, okay, Euler's diagram or Venn diagram or logical reasoning question. Usually it will be three. Okay, Prof. Inshira.
Mr.
Akwan, you see, we're done with the question.
Yes, we are done.
And we have, you see the way we place all the people in the Venn diagram. It's like it came after the A, which tells you the Venn diagram. So they mark all these placements.
Yes, they
like
will mark.
in an exam.
They will mark.
So it's all parts.
The thing is, okay, what you are doing here, the placement and what have you, is what will help you do this. So it's just like evidence of work.
Oh, okay.
You get the point?
Yes, please.
Okay, very good. All right. Okay, so I think we can move on to the next, okay, question. So let's see. what the next question, okay, has for us. Okay, so now, okay, question 2, consider the following statement. Can you see clearly? Can you see
Yes,
what
please.
I have here? Okay, so you can read. Okay, so consider the following statements. So this time around, you have statements. How many of them? 2 of them. Okay, all mathematicians are clever, so you can see that keyword there. Okay, so you underline. Okay. And if you come to the second one, no clever, so you underline. Okay, so now let's go and, okay, you read everything, but hey, you are asked to draw a Venn diagram. And Venn diagram, you need to get the representation for the sets. Okay, so what do we have? We are going to have, okay, if you look at what we have there, indirectly, we are dealing with persons or people again. I hope you are with me. Our general set will be, oops, my mu is looking too ugly. Let me clear. Okay, oh, even in this mode, I can go back. I thought I was still in the presentation mode. Okay, so mu is equal to, or if you want to use epsilon, you can. Okay, a set of people or persons. Okay, comma, your next, okay, so your statements will bring out, okay, the set. And this statement, like I said, okay, usually will connect 2 sets. Either the set is already, okay, represented and a new one introduced, okay. So let's see, all mathematicians are clever. Okay, so it means how many sets of people are we looking at here?
2.
2, which will be?
Mathematicians and clever.
And clever. Please, do you all agree? Are you all with me? Okay, so in this case, I am going to use, I'll come down. I know it won't go there. So you let me write M, okay, to be equal to what? A set of mathematicians. Okay, then what else do we have? Okay, C for clever. Okay, so let's see. We are done with our first statement, bringing out the set. Okay, let's look at the second, okay, statement, the why. No clever person is selfish. Okay, how many sets can you see in the second statement? How many? How many sets?
2.
2, which will be?
Clever and selfish.
Clever and selfish. But you can see that already clever is catered for. Is that clear?
Yes.
So we are left with what? Okay, selfish, okay, to deal with. So in that case, I will come and write and. Please, are you following?
Yes, please.
Yes, please.
And S will be equal to selfish. Okay, so now, okay, like I said, okay, so let's go and have our Venn diagram drawn. When we come to the B, we'll make our representation for the names. Okay, so that is what we have there. Okay, like the space here, let me get the names here. Okay, so in this case, I'm doing all my representation because I have my letter here. So I'm going to write maybe comma. The small letter A will be for Ali. Is that clear?
Yes,
okay,
please.
small letter B, okay, will be for Baba.
Baba.
Okay, then did I hear Baba? Okay, then the last one, okay, will be Ama. We've used A, so we cannot use, okay, A to represent Ama. So let's go for M. Is that clear?
Yes, please.
Okay, so Ama. So we've done all, okay, the labeling. Okay, so now the red tax begins. Okay, so let's see. The first statement, okay, we can see all mathematicians are clever. Okay, so we said all means was subset. Is that not it? And the set that comes immediately after the all, okay, becomes the smaller set. So it means M must be in C. Is that clear? Must be contained in C. Hello, are you with me? Here, this time around, we have 3 sets. So we are going to draw 3 circles. So take note. So the first one is what I have drawn here. Okay, the second one is going to be inside. So that will be inside. Again, let me reduce it a little. Okay, and place it well, maybe inside. Okay, so this is from the first statement. And we have what? All M, okay, being C. And don't forget your immune. Okay, is my point well made?
Yes, please.
Okay,
Yes,
so let's go and look at, okay, our second statement. No clever person is selfish. When you see no, what type of set did I say it is under consideration? Disjoint. So we are connecting with set C and set S. Is that not it?
Yes.
So it means the set S that I'm going to draw, represented by a circle, it should have nothing to do with what? The C. Okay, it shouldn't overlap. Okay, so this is what I'm going to do. Okay, let me copy and paste. Okay, so and move. So I'm going to move it to the side, make it a bit small so that it doesn't overlap. It's overlapping. Okay, so it doesn't overlap. It shouldn't overlap. Okay, so, and I can move it to the side. Okay. So I can say that, okay, this is representing my set S. Is my point well made?
Yes.
Okay, so remember, the key is the Venn diagram because that's what we are going to use. So if your Venn diagram is wrong, okay, issues, obviously you started on the wrong foot. So you should know what the future holds for you. Okay, so we are moving, we are done with A. We go to B. Okay, so BI. Okay, so now, okay, this is where you can see that we have 2 statements, one before the implication sign and one after the implication sign. The before statement, I said, what do we use it for? The before statement, what are we supposed to use it for? Hello, my professors.
To place the letter.
Okay, very good. The name, the letter. So to place, get all the possible position for the letter. So now the name is Ali. A is clever. So if A is clever, then where should A be?
At the C region.
Yeah, inside the circle for C. Is that not it?
Yes.
But you can see that because of the M here, the circle for C is now in 2 regions. You get it? Because of the M, okay, the M has introduced another circle in C. So in that case, or another region in C. Originally, if the M is not there, it's only 1 region. But immediately you draw another circle, you have 2 regions. So it means my A will be here, so dot A. Okay, or it could be inside dot A. These are the possible, okay, regions that you can place, okay, your A, all the possible regions. Should I come again? Hello, should I come
No.
again? Oh, the first time I've heard no to this question. Okay, all right. Okay, so now, once you get your position, let's go and look at the second statement. The second statement is saying that Ali is a mathematician. So if I'm able to get, okay, A in the diagram here, who is outside M, who is not a mathematician, then I've been able to counter. You get it? The original statement here is A is M, is a mathematician. But if I'm able to get A who is not a mathematician, then I've been able to counter. Otherwise, I have not. So let's see. This A here is a mathematician, true or false?
True.
This A, is it a mathematician?
No, please.
No.
Please
So it
come
means,
again.
should I come again? Hello, should I come again, or my point is well made?
Please come again.
Please
Okay,
come
from
again.
where? From where? As for the placement, you said you are all fine, right?
Yes, please.
Okay, so once
Yes.
you place, okay, you use this to place, then it means the first statement has been catered for already. So cover this and use this one, okay, to do your arguments. So here, so what we have here is A is a mathematician. So meaning, if I'm able to get A, who is not a mathematician, okay, so the statement is A is a mathematician. So the counter will be not a mathematician. A is not a mathematician. So if I'm able to get A who is not a mathematician, then I've been able to counter, otherwise no. So if I come here, A is a mathematician, it doesn't counter, but that doesn't exhaust all my A. I have another A to test, you get it? Okay, but this A is not a mathematician because it's outside M. So per this statement, you are saying that if A is inside what C, then A strictly must be inside M. Meanwhile, I have A who is inside C but not inside M. You get it? Okay, so in that case, that's A here that you have here has been able to counter. So that will give you not, okay, valid. Okay, we move on to the II. Okay, II, what do we have?
Baba.
It's not selfish. Okay, so if Baba is not selfish, then it means Baba must be outside the circle for selfish, which is S. Is that clear?
Yes, please.
So if you are outside S, okay, these are the possible regions. You could be here, you could be here, or you could be here. Is that clear?
Yes, please.
Who wants me to come again? Okay, so in all, you have 1, 2, 3, 4, 4 regions. So it means if you are not in one, which is the inside here, you should be in the other 3. That is the meaning. So the other 3 will be, so positioning Baba will be outside S, which is 1 is here. Okay, 1 is here, still outside S, and 1 is here, outside S. Oops. Is that clear? Hello, is my point well made?
Yes, please.
Okay, so now let's come to the second statement. The second statement means the Baba that I have here should strictly be in M. So if I'm able to get any Baba who is outside M, then I've been able to counter. Do I have any B outside M?
Okay.
Yes, please.
Yes, you have this B outside M, you have another B, you have 2 of them outside M. 2, 1, 2. So you cannot say no. This is the only B among the 3, okay, B's. This is the only B inside M. The other 2 are not. But even we said 1 is sufficient. How much more 2? 1 is okay. So you just use 1 of them. So in this case, you'll be able to counter because I have a Baba, okay, who is not what? Okay, selfish. Okay, but not what? A mathematician. Okay, so in this case, it will give me not what? Valid, because I was able to counter. Is my point well made?
Yes, please.
Okay, let's go and look at III. The last one, okay, for this particular question. Okay, Amma is a mathematician. So it means Amma must be in which region? Which circle?
M.
M. Okay, and the circle for M, how many regions can you see?
One.
Only one region. So it means you get only one position for your AMA. And AMA, we said we are representing that by M. Okay, small m. So you have small m here. Only one. Okay, so now let's see. This one is only one that you use to do your argument. Okay, so let's look at the second statement. Okay, the second statement is trying to tell us that you should have A strictly outside what? S. And this A, sorry, did I say A? It's M. You use M for AMA. Okay, so you should have M who is strictly outside what? S. So if you are able to get any M who is inside S, then you've been able to counter. Are you able to get any M inside S?
No, please.
Okay,
No.
because the statement here is AMA is not selfish. So the counter will be AMA is selfish. You get it? The counter will always negate the statement. So if I'm able to get AMA who is selfish, then it means I've been able to counter. I don't have any A inside what? S. So my only A here is outside S. So in this case, the statement is valid. All correct.
Yes, please.
Mr.
Okay.
Hartman, M
Yes,
or
please.
A?
Come again.
Please, M or A? We are talking about AMA.
In fact, M, I mean M. Okay, because we are using the first letters. So M, I'm able to get only one M. Okay, who is what? Here, but you can see that that M is outside S. I'm not able to get any M which is inside S to counter. Okay, unlike the other one, this one, we said Baba is a mathematician. So if the counter would be Baba is not a mathematician. So if I'm able to get any Baba who is outside M, then that will counter. And I have two Babas here outside M. So obviously I'm able to counter. You get my point. Okay, so if that's the case, now let's go and look at the following past questions. Today is very likely maybe we'll go for our break, or maybe after 1 hour, 30 minutes, we'll go for the break. Okay, I think, let me see. Let me enlarge it a little and see whether it will be, oops, okay, clear. Okay, I will need space here for my representation. Okay, can you see clearly? So these are past questions, so obviously. So let's see how best we can make do. So the questions will not be different from what we've done so far. So the following statements are true for a certain school. Okay, so all good students in English language are in the debating club. Okay, so now we know we have to get our set. So let's start. If for nothing at all, we all know how we are supposed to start. By then, we had read through all the question and we know, okay, what the question entails. So we know that we are dealing with a Venn diagram, sorry, a logical reasoning question. Okay, so now it's not always that, just like Venn diagram question, it's not always that the first question would be draw the Venn diagram. We can ignore this and ask you to do this, and you will need to draw the Venn diagram. So you have to always go through, okay, the Venn diagram or the Euler's diagram. Is that clear?
Yes.
Yes.
Okay, so now, okay, we are going to let. Okay, so we define our set. Okay, so let's see. Okay, the statement of a best. So it means we are dealing with students because we are talking about a certain school. So we are dealing with, so our overall, okay, I mean sets, our universal set will be a set of students. Do you agree here? Please, do you agree?
Yes.
Okay, so our universal set will be, okay, a set of students. So we are dealing with students. Okay, like I said, okay, so let's go for the first statement. We always tell us as we read, okay, we underline the salient parts, one of the key words, okay, that we need to. So all good students in English language are in the debating club. So, okay, which set can we talk about in that statement? Oh, hurry up. As for the set, you should be able to. This one is just English. Pick out the set in that statement. Okay, so good student in English language is one set. And okay, student in the debating club is also another set. Or debating club is another set. Is that clear?
Yes.
Yes.
Okay, so we are going to look at what good, okay, in English language. We are dealing with students. So I can write Jane will be equal to, okay, a set of good, okay, in English, okay, language. And obviously, I didn't write a student because our universal set is students, so we should know that we are talking of for students. Then, okay, the next set would be what? Okay, debating club. So D will be student in the debating club. Then you close it. Okay, it's a set. So don't forget your curly bracket. Okay, so let's go to the second statement. Okay, the second statement, okay, there is no student below 15 years in the debating club. Okay, so we can see our keyword there, no. Is my point well made?
Yes, please.
Okay, so let's see. Debating club is there. Which other set, okay, new set has been introduced there?
Students below 15 years.
Very good. So we are talking of what below, sorry, 15 years. So in this case, I'll write B. I will use B to represent, okay, below, okay, 15, okay, years. All correct. Hello, are we all fine?
Yes, please.
Okay, great. So if that's the case, then now we come to, so this time round, okay, because I don't have space here, I will, okay, bring my names, okay, when I write, okay, the I. So I is the Venn diagram. So that is what I'm going to do, or we are going to do together. Okay, so let's go. And you've drawn your rectangle already. So let's go for our first one. We said all, so we are going to get one in the other. So a bigger set and a smaller set. And the other one too, we see no. So obviously, you know, you are going to have another set which will not intersect, okay, a set, because we'll be talking about what? Disjoint sets. Okay, so this is what we have for the first, okay, statement. So we have all good, okay, students in English, and good students in English represented that by Jane. So all Jane, okay, must be what? Must be, okay, in D, debating club. So D will be here. All correct. Let me write my Jane well. All correct.
Yes.
Yes,
Very
please.
good. Okay. Please respond quickly. Okay, then the next, so we are left with one more set. Okay, and the second one, we are looking at students below 15 years. Okay, but we are told that there is no student below 15 years who is in the debating club. So below 15 years students and a debating club students, they have nothing in common. So these two sets, they shouldn't touch. They are disjoint sets. Is my point well made?
Yes, please.
Okay, so on that note, I am going to, okay, do that. Okay, so that will give us, okay, this particular, so outside, that's what we are going to do. They shouldn't, that set shouldn't touch. Okay, okay, let me draw it a little bigger. So it's okay. So now my set for below 15, so B. So you can see that this one, the diagram is similar to the one that we just, okay, finished. Okay, so is that clear? So, however, the questions that will vary, usually vary a little. So let's go and see, okay, what we have there. Okay, so quickly, let's go. Okay, so the first statement, which maybe is, so I have Sandra, so I'm going to have what? I, so I'm done with I. So I'll come and write let's, and I will need all the names. So small s will be equal to Sandra. I hope you are following.
Yes, please.
Then the second name, we have Oloye. Okay, so Oloye is what? Okay, so that will be for O, but I want to avoid using O. Is that clear?
Yes.
So which letter do we go for? Let's go for L.
L.
Okay, very good. Okay, L will do. Okay, then, okay, another name, last name. So, and, okay, your last
Peter.
name we have, that is Pierrot, Peter. Okay, so P, small p will be equal to, okay, Peter. Okay, so we are done. So now we come to alpha. Okay. Okay, so alpha, what are we supposed to? What's the statement? Sandra is not in the debating club. So it means Sandra must be outside, okay, the circle for D, debating club. Is that clear?
Yes, please.
Okay, so this is the circle for D. So if you are outside, you are here or you are here. Is that clear?
Yes, please.
Please, are you sure you are following? Make sure you get it. Oh, I've told you. Okay, logical reasoning questions are easy. Okay, and definitely it's very likely you will see it. Okay, so now what do? We are going to position our first name, which is S. So S should be, it could be here, anywhere here, so S, or it could be inside B. All correct?
Yes, please.
Okay, so now let's look at the second statement that we use to, okay, do our argument. Sandra is not good in English. So what will be the counter statement? If you want to negate this statement, if you negate it, okay, what will be the statement? If the original statement is Sandra is not good in English, the counter statement will be?
Sandra is good in English.
Very good. So if we're able to get, okay, Sandra, who is good in English, meaning Sandra, who is good in English is Jane, then we are good to go. Otherwise, okay, we will say that it is what valid. So are you able to see any S who is inside Jane, representing students good in English?
No, please.
Okay, so are we able to counter?
Yes, no, please.
Did I hear yes? Or you change your mind?
No, please. We are not able to counter.
We are not able to counter. Okay, so it means the statement is valid. Well, it's very easy. Just though it's technical, but it's very easy when you get it. Okay, the issue is get the right, all the positions, all the placements. If you get all the placements, your work will be very easy. Okay, so let's look at beta. Okay, beta, what is the statement? What is the statement?
Oloye is not good in English language.
Okay, so it means we are going to use the first statement to position what or place what Oloye, which we represented by L. Okay, so it means L must be outside what Jane. Do you agree?
Yes, please.
Okay, so this is Jane. So if you are outside Jane, okay, the possible regions will be here, it will be here or here. Do you agree?
Yes.
Okay, in all, I've told you that you are going to get 4 regions. So if you are saying that 1 region is taken out, then you'll be left with 3 regions. So that's where, okay, you get your possible placement. So L could be here, one of the outside was J. Okay, L could be here, another outside J, or L could be here. All correct?
Yes, please.
Okay, so now the second part of the statement. Okay, Let's read the second part of the statement, the direct statement. Oloye is below 15 years. Is
Below
that not
15
it?
years.
Okay, so it
Yes,
means
please.
what will be the counter statement?
Oleye is not below 15 years.
Okay, so it means if you are able to get Oleye, okay, who is outside what P? Okay, it will counter the statement. You get the point?
Yes,
Yes,
please.
please.
Okay, so let's see. Do you have any Oloye who is outside what P?
Yeah.
Okay, you have how many of them? 2. Can you see that? Should I come again?
Yes, please.
Hey, okay. Okay, where lies the problem?
It's the second part.
The second part. I've told you the original statement is, okay, Oloye is below 15 years. So what will be the counter statement?
Oloye is not below 15 years.
So if you are not below 15 years, it means you are outside the circle for what? Okay, B. Do you agree?
Yeah, yes, please.
So it means your purpose is to get, okay, L, which is representing Oloye, outside what? B. If you're able to get even 1, you are able to counter. Because that's your counter statement. You get it? So if your counter statement is satisfied, then it means, okay, you are able to counter. So the counter statement here is Oloye is not below 15 years. So if I'm able to get L outside, okay, outside what B, then that would be the counter statement. And you can see you have 3 L representing Oloye here, but 2 of them is outside what? Okay, B. So in that case, what are we going to do? Okay, we know
Not valid.
even 1 is sufficient. How much more? So in that case, we are going to get not valid. Afa.
Afa.
Okay, all right. Then the last one is what? Gamma. Okay, very soon I will make that determination by giving your own set of questions. So let's see. Peter is not below 15 years. That's the first statement. So it means Peter is supposed to be outside when you are going to place. This is the meaning. Peter is supposed to be outside, okay, B. Is that clear?
Yes, please.
Okay, so this is what the circle for B. So we use P to represent Peter. So outside what B will be this region, or this region. Do you agree?
Yes, please.
Okay, so I am going to put, okay, P1 will be here. That's not to say this is the exact position. Once it's anywhere outside, okay, it's okay. Then you have 1P also here, small p. Okay, and you could have another P inside here. All correct?
Yes, please.
Okay, so 4 regions, 3, okay, obviously 1 no-go area, so it will remain in the other 3. So now let's look at the second part of the statement. Peter is in the debating club. Okay, so this is the direct statement, the one that is given. So the counter statement will be?
Peter is not in the debating club.
So it means if you are able to get any P who is outside what? The circle for debating club, which is D, okay, you've been able to counter, otherwise you are not. Is that clear? So your purpose is to find a circle outside what D. Sorry, a P outside what D. Okay, so now let's come to your D. The whole of this is your D. Do you have any P outside D?
Yes, please.
Yes,
Okay, you have
please.
1 here. So it means that counters, and that will give you, okay,
Not valid.
You get the point?
Yes, please.
Okay. A lot of teachers will run away from this. It's technical. So we usually ask students to go and read. Okay, let's try it. But if you've been able to, okay, understand, then you are doing well. Okay, all right. So now, okay, are we all fine? There's the third question. Okay, so let's move on to the fourth one, and let me see if you are fine. Then, okay, so let me see. Only one statement. So this one, haven't we done this? Is it not the same question that we did? Or it's not the same? Okay, I think I will leave this one with you, or maybe as a class exercise. Only one statement. All good literature students are in general art students. So you can see only 2 sets here. So that would be your first, okay. This one is just like the very first one that we solved. It's only 2 sets. Okay, so I'll give this one to you as a class. Okay, work. So let me move on to the next one. I want another 3, okay, sets. Okay. So this one is quite different, and after that we'll look at one more question. I will just draw your attention to something, a very important information, then we are good to go. So with this one, as usual, okay, as you read the question, okay, and you underline the salient parts, you have all. Okay, so we'll come to that. Very vital information will come from what we have there. So solution, let's define our set quickly. So let's, what are we dealing with?
People.
Okay, people, do you agree? Okay, so we are dealing with a set of people. Okay, so let me use mu to represent my set of people. Okay, very good. Oops. Okay, then let's look at the first statement.
Policemen.
Policemen, is that all? Only one set that he can the statement.
Wear uniform.
Okay, so indirectly I will use, okay, policemen and uniform. Is that clear? Or wear uniform. Okay, indirectly. So let me see. We are going to get, oh, in this case, the set we're given. You didn't read through the question well. Okay, so that's why I said read through, finish reading. So here our representation already done. Okay, is the universal set that was not defined. Okay, so you can ignore, if it wasn't defined, you can ignore. But once you write it, no issues, then the other set will be here. So we are told specifically to use P to represent. And anyway, that was the more reason why I picked this question, because this time around, okay, the sets are defined, so you cannot give it your own, okay, names. Is that clear? Policeman. Okay, then T.
Yes.
So you extract, okay, all the sets that you have there. Let me save time. Is that clear? So you extract what you have here. All correct?
Yes.
Okay, then we come to I. I is the Venn diagram. Okay, draw a Venn diagram to illustrate X and Y. Okay, so let's see how best we can illustrate X and what and Y. So the first one, the statement X, all the keyword is there. So, and we said we are using P for policemen. Okay, and that's what comes, and I said that comes directly after your all. Okay, so that becomes the smaller set. So you are dealing with subsetting. So let me go and pick. Okay, so indirectly, I'll be dealing with this. All right. Okay, so this is what I have. Let me make it a little big. Okay, so that if I have more names, it can contain that. Okay, so that will be it. And that is, okay, P must be those who wear uniform. Okay, what is the set representing that T? Is that clear?
T. Yes, please.
Okay, so let's move on to the next statement. Civil servants, is that not it? Do not. So we have another set, which is what, civil servant. And we even know that that is even given here. So let's see. Civil servants do not wear uniform. So what does that mean?
Disjoint.
Disjoint. Please, are you with me?
Yes, please.
So indirectly, it means no civil servant wears uniform. Is that clear?
Yes, please.
Okay, all right.
Yes.
So you didn't see your keyword there, but indirectly you know the meaning. Okay, that's the more reason why I picked this question. Okay, so that you know that it's not always that in a statement you see your keywords there. So if you get to see your keyword, you thank God. Okay, so now I think we are good to go. Okay, so that's okay. All right, so I'm going to have my C here. Okay, so my Venn diagram done based on the two statements. Okay, so we are going to move on to, okay, the I. So I, what do we have? The names, is that not it? You want to check the validity or otherwise. So the names, okay, must be, and how many names? We have two. So small a, we write let's, okay, small a be equal to what? Edu. Is that clear? Okay, and the O, we won't use O. So F, small f, will be equal to Ofe. Is that clear? Okay, so now let's go and look at alpha. Alpha, what are we supposed to? So let me see whether, okay, I can call one of you to get me the positions in terms of, okay, so Prof. Mamijan, okay, let's go. Okay, let's see how you can place the first statement, alpha. What position, how would you place your name, which is what? Edu. Just try. Okay, if you get it wrong, we are learning, you learn. Okay, so Edu, wears uniform. So where are you going to place Edu?
So Edu is going to be in T and in P.
In T and in P.
And
okay, so it's supposed to be, if you say it's supposed to be in T and P, then you are trying to say that P is not part of T. So it's supposed to be in T, but T is made up of what, two regions now. You get it?
Yeah. Yes, please.
Okay, very good. Okay, you will finish. Okay, let me see. You started very well. So I'm so sure you will finish, okay, very well as well. So our A, so dots, one will be here, one will be here, possible. Okay, so you have all the possible positions or regions for A. Okay, so now, okay, Mamijan, still let's look at the second statement. Okay, so Edu is a policeman. Okay, so what will be the counter statement?
That Edu is not a policeman.
Okay, so your duty is to do what before you can counter? Find A, who is outside P. Is P for policeman? Yes. You get it?
Yes, please.
And you are able to counter. So do you have any A outside P?
Yes, please.
Okay, so are we able to counter?
Yes, please.
Okay, so what will be our conclusion?
That the argument is valid.
No, you are able to counter.
It's not valid, sorry.
It's not valid. Once you're able to counter, it becomes not. Okay, valid. But if you are not, then it becomes what? Valid. Okay, so beta, another person. Okay, thank you very much. Okay, Prof. Okay, Mamijan. So let me see. Okay, because I started calling names, some people are running away. Okay, I won't mind them. Okay, Prof. Leroy, let's go. Beta. Okay, let's get the placement of Ofe, F. Prof. Leroy, are you there? Hey, people are running. I started mentioning them now from 16 to 10. Hey, Prof. Leroy, let's go. Just try. If you get it wrong, you learn. Don't be afraid. Hey, it's now 9. Okay, so let's go. Prof. Leroy, let's go. Wow.
Sir.
I can hear you now. So let's place Ofe, F. What will be the possible regions for F?
P.
P. So P, how many regions do you have in P?
1.
1. So it means Ofe, this is the only place for Ofe, which is F. Okay, so now let's look at the second statement. What's the second statement?
Ofe is not a civil servant.
Okay, so what will be the counter statement?
Ofe is a civil servant.
Okay, so what is your duty? To counter. Your duty is to find F, which is in what? In C. Or is C is for civil servant. It's in C.
So say F in C.
Yes. Your duty is to find F in C. If you're able to find F in C, then you've been able to counter. Otherwise, you are not.
So F in C.
Yeah, do you have any F in C?
No, sir.
So it means you are not able to counter. So when you use the first statement, your first statement will give you all the possible regions that you can get your name. So you know that you've not left any region, okay, that your name possibly could be. You've not left even one. So all possible regions. Then you come to the second. The second is trying to tell you that, okay, per this statement, okay, we have Ofe is supposed to be outside, okay, civil servant. But if we're able to get any Ofe, okay, who is inside civil servant, then that will be your counter. So I ask myself, after my placement, do I see any F in C? No, there is no F in
No,
C.
sir.
So it means I'm not able to counter. You get it?
Yes, sir. So
it means if F is a policeman, it definitely means that F is not a civil servant. So whatever I have here is a valid statement. Please take note, validity is different from what? Being true or false. You get it? Validity and true, not the same. Okay, so valid. Is my point well made?
Yes, sir.
Okay, very good. Okay, so that will be it. Okay, for today's meeting. However, there is one information that I want to put across, and maybe I will ask you to try the rest. So there was one information. Okay, so let me see. Okay, so this is it. Okay, so now whenever you are labeling your set, make sure you label your set positively. And by that, this is what I mean. If you look at this statement, okay, the first statement, obviously you can see students with measles and sick bay. So you have measles and sick bay as your sets. So that is positive. Student with measles, okay, then sick bay. You didn't say students not in sick bay, students, okay, not with measles. That is the negative. Don't define in the negative. So now what do we have? All students in the sick bay do not do homework. So you can see that here you have what? Sick bay, then do not do homework. So obviously when you are representing your set, don't write, okay, H to be equal to not do homework. H will rather be do homework. You get it?
Sir.
Yes, please.
Now I'm talking about your definition, your set. When you are defining your set, don't define your set in the negative. You shouldn't have not in your definition of the set.
Okay.
You get the point?
Yes, sir.
Yes.
So here, though you see do not, okay, when you are representing your set, say, okay, go for those who do their homework as your set. That is the positive. You get the point?
Yes, please.
Okay, so now let's see what we have in the statement that is here. All students in the sick bay do not do homework. So what does this mean? Okay, so obviously, okay, can I say that, okay, this is the same as no students in the sick bay, okay, okay, that's okay, his or her homework, let me put it that way. Can I say that?
Yes, sir.
Okay, so this is my point. Anytime you see all and you come and see not, okay, all and not, okay, will be equal to no or none. Is that clear?
Yes, please.
If you see, okay, no, okay, plus not, will always give you what? Will also give you all. You get the point?
Yes, sir.
So take note of these key, okay, words. Is my point well made?
Yes, please.
Okay, very good. So if that's the case, okay, this brings us, okay, to the end of today's class. Okay, and okay, to the end of what's the topic, logical reasoning. And like I said, okay, I'm going to give you 2 questions to try. I'll put it on the platform though. So this is the first one, okay, and the second one I think will be this. Okay, this particular one, okay, should be okay. This one, is it okay, 2, okay, statements. So I'll put it on the platform for you. Okay, so thank you very much. Okay, enjoy the rest of your evening. Okay, so bye-bye. God bless us all. And try your hands on all
Bye.
the questions that you see. Okay, you can relate now. Okay.